Hello all. So this year we are doing the lesson on Valentine's Day. So if two geometric figures have exactly the same shape and the same size, they are what? They are congruent. And you guys have heard this word before, so it shouldn't be anything foreign. But when you hear congruent, you should think the same or equal. So you can see that these are the same size, they're just rotated a little differently. They're still congruent. So today, we will be talking about congruent triangles, and you'll be able to recognize and solve for missing parts of congruent figures. So in the first one, two polygons are congruent if and only if their corresponding parts are congruent. So you can see that angle A here is congruent to angle H with the two lines marking it. You can see that angle B is congruent to angle J. And that angle C is congruent to angle K. So note the little dashes on those for congruence. Now matching up our sides, we see that side AB has the one tick, so that is congruent to side HJ. And be matching up those parts. Note how A and H were congruent, so that's why we're putting A and H both first. So make sure you're matching those up correctly. Also, side AC is congruent to side HK. So here you can see our three ticks. And we have side BC is congruent to side JK. Now, since all of these parts line up, all angles are congruent and all sides are congruent, we can conclude that triangle ABC is congruent to triangle HJK. So here we go. In the diagram, triangle ABC is congruent to triangle DFE. So find the values of x and y. So ABC, I'm going to match up with DFE. So I'm going to actually write BFE here because our D and our A match up because they're both first. And then our B and our F, and then our C and our E. And so then I'm going to label, we see that EF is actually 2y plus x. So I'm going to put that up here. And that angle F here is 8y minus 5. So I'm going to put that here, 8y minus 5. So now I can solve for x by setting, or I think I have to solve for y first by setting 8y minus 5 equal to 99. Okay. So then you get 8y equals 104. And you get y equals 13. Now that we know that y equals 13, we can plug that in and solve for x. So we also know that 38.4 equals 2 times 13 plus x. So we get 38.4 equals 26 plus x. So we're going to get that x equals 12.4. Our next diagram here, we can see that RSV is congruent to triangle TVS. So we're going to find the values of x and y again. So triangle RSV lines up with TVS. So you can see they're almost like flipped upside down. So we know that angle T lines up with angle R. And we know that angle R is 180 minus these two. So we can get 180 minus 90 minus 78. So we get angle R equals 12 degrees. But since T and R line up, we know that X is 12 degrees. And then solving for Y, we know that SR is the same as VT. So we can set 24 equal to 2y minus 1 to give us 25 equals 2y, and therefore we get y to be 12.5. Another theorem we have is the third angle theorem. So if two angles of one triangle are congruent to two angles of a second triangle, then the third angles of the triangles will also be congruent. So we know that angle A here is congruent to angle F, and that angle B is congruent to angle H. So therefore we know that angle C has to be congruent to angle G. So we can take 80 and set it equal to 2x. Solving for x, we will get x to be 40. Over here, very similar again, we're looking for x, and we know that angle M is congruent to angle Y, so that would make this 51 degrees. And that angle L is congruent to angle Z, which is then 65 degrees. And we know that all three of these have to add up to 180. So we can get 180 minus 51 minus 65 has to be our angle X. And so we get that to be hang on a second. So we're going to take 180 minus 65 minus 51 and set that equal to our 4x. And then we can solve for that by combining to get 64 equals 4x. So then we get x is going to be 16. Sorry to confuse you on that last part. So section 3.3, we're going to be proving that triangles are congruent with some of these different theorems. So you're going to be able to justify triangles are congruent using triangle congruence theorems. But first, we're going to talk about what postulates and theorems are. So a postulate is a statement that describes a fundamental relationship between the basic terms of geometry. And postulates are accepted to be true without proof, so they're assumed to be true. A theorem is a statement or conjecture that can be proven true by undefined terms, definitions, and postulates. So take note of those definitions. So our first theorem is side-side-side congruence. And so if three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent. So on our figure to the right, we have side AB is congruent to side DE. So that is a side. And we have side BC is congruent to side EF. And that's another side that's congruent. And then we have side CA is congruent to side FD. So that's another side. So therefore you can see our side, side, side. And we can conclude that triangle ABC is congruent to a triangle DEF. And make sure that you're matching up those parts again. Triangle ABC is not necessarily congruent to triangle EFD. You have to match up the A's and the D, the B and the C, and the C and the F correctly. Our next theorem is side angle side. So we have side AB is congruent to side DE. So that's a side. So we can see AB is congruent to DE. We have angle B is congruent to angle E. So that's an angle. And then we have that side BC is congruent to side EF. there. And so therefore we can conclude that triangle ABC is congruent to triangle DEF. Another one we have is angle side angle congruence. So we can see that angle A is congruent to angle D with the tick marks. And then side, so that's an angle. Side AB is congruent to side DE. So that's a side. And we have angle B is congruent to angle E. So that's another angle. So we have triangle ABC is congruent to triangle DEF. Our last one that we're going to look at is angle side. So we have angle A is congruent to angle D. And we have angle B is congruent to angle E. And then we have that side BC is congruent to side EF. So note that we start at the angle, then we go to another angle, and then we have a side. So we have angle side for our theorem. And we can conclude that triangle ABC is congruent to triangle DEF by this. So just for a little practice, why don't you look through these? The first one, you can see we have 3 sides being congruent. So we have side, side, side. For the second one, we cannot conclude this. There is not enough information. So we can conclude that this is congruent, but then we only have 2 sides. For C, we have that we cannot conclude this because we have side, side, angle, and side, side, angle does not work. So that one is not one of our theorems. And then we have that KM bisects JML, so that means that this angle is congruent to this angle. And we also know that since these share sides, the sides are congruent. So you can see that we have an angle, and then an angle and a side. So we have angle, angle, side. So yes, we can conclude that. So again, note that side, side angle does not work. Now we're going to find the value of x. So these 2 triangles are congruent. Triangle BCD is congruent to WXY. So I'm going to match up those parts. I know that angle W is 77 degrees. And I know that XW is 2x plus 5. So we can either solve for x by finding the sides or the angles. I'm going to take 11, set it equal to 2x plus 5 to get 6 equals 2x, and I find that x equals 3. So again, you could do that with the angles, and you'll again get x equals 3. So here's a little more practice. Can you prove these are congruent? This one, yes, because you have side, angle, side. So that was one of our theorems. Then here, since that split sum is on both, we have side, 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 so yes. And then again here, we have a side, but we have angle, angle, side. So that's a yes. Here we have just one angle and one side, so we don't have enough information. Here we have an angle that is congruent and 2 sides that are congruent and then congruent to itself. But here we have a side and then angle. So side, side, angle. Again, remember that did not work, so no. And then here, by vertical angles, these are congruent. So we have angle, angle, angle. But again, that's not enough information to tell us that they are congruent because They might just be similar. So again, that is no. Thank you for watching and listening. Look forward to seeing you in class.